Okay, these are examples of how to determine the rate law experimentally. Okay, and so the first thing is to select which two experiments are we going to be using. Okay, and so first thing we want to do is, if we're looking for A, then we want to, so we're doing, so this is for compound A. Okay, then we are looking for the compound that is different than the rest. So looking at this column, which compound is different than all the others, concentration-wise? And it is this one. Okay. So for the one I'm interested in, I look at this column. Okay. Then I come over. I should have highlighted this one too. Sorry. I want to do the whole row. All right. And then for the second part is that the other species, in this case there's only one, which is B, okay, must have one that's equal. So I'm looking for one that's equal to this 2.2 times 10 to the minus 3. So my choices are this one or that one, okay, and we're going to make it this one. So these are my two experiments that I use for the determining for A, okay, and I don't have these numbered, but we're going to say this is experiment 1, 2, and 3. Okay, so the highest concentration on top, okay, so between these two, the highest concentration is the 12.8. So the formula is going to be the concentration of A for experiment 2 over the concentration of experiment for 1 raised to the m, oops, equals the rate for experiment 2 over the rate for experiment 1. Okay, and so now I'm just going to plug in these numbers. Okay, so I have 12.8 times 10 to the minus 3 over 6.4 times 10 to the minus 3 raised to the m is equal to 1.0 times 10 to the minus 4 divided by 2.6 times 10 to the minus 5. So I'm going to divide these. The times 10 to the minus 3, since it's both numerator and denominator, goes away. So 12.8 divided by 6.4 gives me 2. The 1.0 times 10 to the minus 4th divided by 2.6 gives me 3.84. But we're going to say that's actually 4. We're going to round it to a whole number. Okay, I forgot the m. So what power do I have to raise 2 to equal 4? So m is equal to 2. So that's the power of the coefficient for A. I'm sorry, the power of the concentration of A. Okay. Now, I don't have a whole lot of room on the slide, so I'm going to erase all of this. Well, I guess I'm just going to do it this way. Then we'll leave the stuff at the top. Okay. And erase this and that and this. Okay. Now, see, for B, well, let me go back to this. So M is equal to 2. Okay, so now for B, starting back in the green, the series that I'm interested in. So I'm doing B this time. So therefore, I'm looking in this column, which one is different, and it's the 4.5 times 10 to the minus 3. So I highlight this row. Okay, and then for the one that I'm not interested in, which are any other species, and this one only has the 1, I'm looking for the one that's the same as this 6.4. So that's also going to be experiment 1. So for B, okay, the highest concentration still goes on top, so it's going to be the concentration of B for experiment 3 over the concentration of B for experiment 1 raised to the n is equal to the rate for 3. So whatever number here has to go here over the rate for 1. And now I'm plugging my numbers. So the concentration for experiment 3 was 4.5 times 10 to the minus third divided by the 2.2 times 10 to the minus third. And this one's n. Okay. So rate for experiment 3 is 5.1 over 2.6. So the rate for experiment 1 times 10 to the minus fifth. Okay, minus fifth goes away because it's on both. Minus 3 goes away because it's on both. So 4.5 divided by 2.2 is 2.04. And 5.1 divided by 2.6 gives me 1.96. Okay, I kind of want these to be whole numbers, so I'm going to say 2 to the m is equal to 2. Oops, these are n, not m's. So n must be, so what power do I raise n to, or what power do I raise this to get 2? So n is equal to 1. So n is equal to 1. So my rate law So my rate law is rate is equal to K times concentration of A squared times B. And then I can use any one of the experiments to find the K. Now on the test, it will be one of them. Okay. When you're doing practice problems, I suggest doing all of them. So if I want to solve this for K, then I'm going to have rate divided by A squared times B is equal to K. Okay, so for 1, it's going to be 2.6 times 10 to the minus fifth is equal to, divided by 6.4 times 10 to the minus 3 squared times 2.2 times 10 to the minus 3. And when I do that, 2.6 e to the minus fifth divided by 6.4 e to the minus 3 squared divided by 2.2 e to the minus third. I get 288.5. Okay. For 2, I do the same thing. It's going to be 1.0 times 10 to the minus 4 divided by this 12.8 times 10 to the minus 3 squared divided by 2.2 times 10 to the minus 3. I get 277.4. And I'm not going to show it, but for number 3, I do the same thing. I'm going to use 5.1 e to the minus 5th divided by 6.4 e to the minus 3 squared divided by 4.5 e to the minus 3. And I get 276.6. I'm sorry, 0.7. So the average K would be the average, so it would be the 288.5 plus the 277.4 plus the 276.7, all divided by 3. And I get 280.9, so 281. So we get 281 is the average K. Okay, so that's the first example. There'll be at least 2 or 3 more videos with more examples here.